This was the original form of the file, all on one line and heavily obfuscated. And this is the deobfuscated portion. Looks so much better, looks really beautiful.
Deobfuscating JavaScript Malware.
Hi everyone, thanks for watching LaurieWired, and in this video I'm going to be manually reverse engineering and deobfuscating obfuscated JavaScript code. Now the code we're going to be looking at today belongs to the async rat remote access tool software, and this software is really commonly abused by malware authors to perform remote commands or even exfiltrate data from a victim's machine. JavaScript code is really commonly very heavily obfuscated, making it much more difficult to reverse engineer. And this is because if you don't have obfuscation inside of JavaScript code, it's really simple to be able to take a look at the script and understand the full capabilities of what it's able to do. If you're reverse engineering obfuscated JavaScript code, the best thing to do is go through, rename all of the variables, rearrange the functions, and try to create an approximated view of what the script looked like to the original malware author before they added the obfuscation, so that you can understand the full capabilities of this script. So let's get right into it and let's see what that looks like. I'm already on my malware analysis machine, and this is a dedicated machine that is secure, and I don't mind performing dynamic analysis or infecting. I'm not going to be directly performing dynamic analysis on this sample, so I'm going to go through this statically and just dynamically analyze certain portions of this as I'm doing the deobfuscation and potentially decoding strings inside of the sample. So I already have my sample downloaded, and I will share the SHA-256 hash in the comments section of this video. But what I want to do first is I just want to open this script file in any text editor and take a look at the contents and see what's inside. So I'm going to open up Notepad++. Let's take our sample and let's just drop this inside. Now right off the bat, you can tell this has a lot of obfuscation inside of it. Probably the most obvious thing that you'll see is that all of this code is performed on a single line. This doesn't change the functionality of the sample, it will still run just fine. It just makes it a lot harder to manually reverse engineer this portion of the file. Additionally, you might notice these weird hexadecimal looking numbers. These are actually valid variable names. They're prefixed by this underscore, and then all of the characters inside of here do make acceptable identifier names. So we can rename all of these to be more human intuitive names as we're performing this deobfuscation process. Now the first thing that I like to do when I'm reverse engineering obfuscated JavaScript is try to fix some of the new lines and spacing so that we don't have all of our code jumbled into one really ugly line. Now there's a plugin that I really like called JS Tool inside of Notepad++. So I'm just going to do plugins, JS Tool, and then I can call JS Format, and all this is doing is going through and fixing all of the spacing and new lines to correspond to what would be commonly expected inside of the JavaScript language. Now I want to take kind of a cursory look and see what's happening inside of here and how much code we're dealing with. It looks like this is pretty heavily obfuscated. We don't have a lot of variable names that provide any indication of what is the potential functionality of this, but I do see some interesting keywords inside here. One thing of note is this ActiveX object. This allows the JavaScript code to interface with the underlying system. So this is really good, interesting portions and really commonly abused by malware authors. So we definitely want to keep that in mind and take a look at that a little bit later. I'm going to do a little bit of a cursory glance, try to find any other strings. This looks very interesting, just immediately. This looks like a sequence of strings inside of an array that have potentially very interesting data. Also, they have little obfuscation techniques inside. This is just performing the hexadecimal version of this character, but this is actually a regular ASCII character, and if you print out this string, it should look like something you would expect. Going on to the rest of the array, it doesn't look like it's in any particular order, meaning that this might get reordered, or maybe there will be functions inside of here that look at particular indices inside of this. But this definitely looks like it's probably going to be referenced later and has some really useful data inside of here. So we'll keep an eye on that as well. Going back up, let's see what else we have inside of here. That's pretty much it for all of the human readable terms that are in here by default. We also have this parse int. This is just a keyword inside of the JavaScript language that's going to allow the program to parse an integer from the provided argument. But let's go through and try to find where the portion of the code is that begins execution first. Now the first thing to note is we have this var up here. That's going to be the first portion that's executed, and we have a couple function definitions. Now one interesting thing to note about this particular function definition is that this is something called an immediately invoked function expression. That means it's going to be immediately executed as it's declared. You'll notice that this is inside of parentheses, and we have other parentheses over here. This is the actual argument passed to the function, so this is going to be argument 1, and then this whole expression is going to be argument 2, passed to this function. This is defining parameter 1 and parameter 2. This is going to execute immediately. So taking a look at this script, the first line of execution is going to start inside of this function, and then we're going to continue on inside of this try-catch statement, where we have a couple other function definitions, it looks like. We've got one defined, and then immediately invoked right after that as well. And then this is simply a regular function, so I'm going to first of all move around my functions a little bit to make the flow of execution just a little bit clearer. Now before I move around these functions, I'm going to quickly make a copy of this code because it's very easy to break stuff as you're trying to deobfuscate your script code, and you might want to reference that original code later. So I'm just going to do copy, and let's move this into a new file. And let's set our language real quick to JavaScript so we can get some nice syntax highlighting. Now I'm going to begin my modification process. So first of all, I'm going to move around these functions so I can see where the execution is starting and where the function declarations are. So let me get rid of this, and let's just move this up here. I'm going to move my regular functions, not the immediately invoked ones, right next to each other. Now we have the flow of control a little bit clearer inside of here. These are going to be functions that are referenced, and then our actual code execution is going to start pretty much down here. The next thing I want to do is I kind of want to start from the top and start deobfuscating a few of these variable names because they're very frustrating to read, and I want to make this a lot clearer and a lot easier to process. So I'm going to start with this variable up here. This is another obfuscation technique. You can see we're setting a variable equal to a function name, this function declared right here. This is an anonymous function call, so we can call this variable just the same. You see it's being invoked down here, and then this is going to invoke this function. So keep in mind when you're reverse engineering JavaScript code, this is a really common kind of obfuscation technique to look out for. Now what I'm going to do to make this a little bit more readable is I'm going to take this variable name and I'm simply going to rename it to this to make it clear what I'm actually invoking up here. So I'm going to do copy, then Control F, and let's just do find and replace, and I'm going to find all occurrences of that variable name, and I'm just going to rename them to the method name. So let's do that. So that's a little bit clearer, and now I'm going to remove this variable entirely so that I know what code I'm going to be calling. Now the next thing I want to do is take a look at the contents of this function and try to clarify the flow of execution inside of here. We have this variable being set to the return value of this function, and this function was the one setting all of the interesting strings that kind of looked like subcommands or subprocesses inside of here. So I'm going to take a look at this function and rename some of the variables to make it a little bit clearer. First of all, I'm just going to Control F and rename all of these to something a little bit more appropriate and human readable. So I'm going to do find and replace, and I'm going to call this array so I know what data type it is. And I'm going to replace all occurrences of this. And taking a look at this is another obfuscation technique. You see that this function is defined up here, but then it's being redefined to return this var command string array up here. So we can just simply get rid of this redefinition and have this by default return this command string. So I'm going to get rid of this invocation since this is just invoking the redefined version. And let's make this a little bit clearer. So I'm going to get rid of that. So all we're doing now is simply defining this array and then returning it. And then that's the actual functionality of this function. So I'm going to rename this function now that we know what it is doing. I'm going to call this malware, MW for malware. And then let's say return command string array. And we'll rename all occurrences of that for clarity. Now if we look at our function up here, this is calling that function and storing the return value, which is going to be this array, inside of this variable. So I'm going to rename this variable now for clarity. Let's call this var, and we'll just say the same thing. Command string array. We'll say copy just to clarify and differentiate between the different portions of this variable used throughout the code. I'm going to replace that. Now this is getting a little bit clearer. Same thing, we have this kind of weird redefinition of a function inside of a function. Let me change some of this to make the actual execution a little bit more intuitive. This redefinition, this is the function name, but we're setting it equal to a new function, which is going to be this, and then immediately invoking that function again with the new behavior. Now I'm going to do the same thing that I did down here and kind of move around the variables and contents of this to make it clearer. I'm going to get rid of this. We have new function parameter names. These are just the regular parameter names, even though they look a little bit funky. Now I'm going to take these and change those here since this is going to be the new definition used inside. Let's do that. And then let's get rid of this return and the second invocation of the method. We'll just remove that, fix our spacing a little bit, get rid of that invocation. And this is a much clearer view of what the method is doing. Now we have this variable, this is just one of the parameters, and it looks like it's setting it equal to itself minus some number. And it's really easy to make this number a little bit more human readable. We're just gonna open up our developer tools inside of our Edge browser. I'm gonna take this code, and this just evaluates to probably some integer number. I'm gonna open up my developer tools. See, we can just do console.log hello world, and it just prints it to the console. So the same thing we can do with this integer value to see what the integer is and make this a little less funky looking. I'm gonna do console.log, and we'll just paste in that integer value. And it looks like it's just the integer 477. So I'm gonna replace that inside of here to make this a little bit easier. Now we're looking at the command string array, and this is passing in this variable, and this to me just looks like an index value. So it looks like we are finding the array string at a particular index and then returning that. Let me just rename my variables accordingly to demonstrate this functionality. I'm going to call this index. So I'll say var index. We'll replace that, make it a little bit readable. Does not look like our second parameter is used, and then if we see other invocations of this, it does look like they're only passing in one parameter. That is allowed in JavaScript, as weird as it is. I'm just going to remove this for clarity since it doesn't seem to be used at all. And I'm going to rename this, getting our index, and we'll rename this variable. We'll just call this var string to return. And there we go. We have two functions that have been basically entirely deobfuscated. Last thing I want to do is rename this function so that we know what we're calling. I'm going to call this malware get command string at index. And this is getting really long, but that's okay because it's super descriptive of what the function is doing. And we'll just replace all occurrences of those. Now these two functions are perfectly deobfuscated, so we can move on to the next portion of code, which is what is going to be executing on the system initially. Let's move on to our immediately invoked function expression down here. And we have a lot of these similar obfuscation techniques. Now we know we've seen these before, these obfuscated variable names, as well as this variable getting set to point to a function, so that we just invoke the function as this indirect reference to that function. Let me get rid of that to make this flow a little clearer. I'm going to Control F, I'll copy this name. We'll just replace all occurrences of that so we know what function we're trying to invoke. And now I can get rid of this variable as well. There we go. Now be careful, don't accidentally think something is a reference to a function when it's just invoking the function. If it has these parameters, that means the function is getting invoked and you're storing the return value inside of this variable instead. Let me look at this interesting loop right here. It looks like we're performing some sort of array operations to remove and shift around the elements inside of the array. My guess is that we're going to be referencing the values in this so that we can get a more clear view of the commands that are trying to be executed on the machine. So I'm guessing this is going to be rearranging that array into something a little bit more sensical here. Let me go through and make sure my thought process is correct. I'm going to look at this. Looks like we're parsing some integer values. Let me rename this so we can see what function we are invoking. This is the parameter of this, which is a little bit funky because we are passing in a function to this. So this really is just a function. And I'm going to rename this for clarity as well. I'm going to copy this and let's rename that parameter. So remember, this is parameter 1. Which corresponds to this. This is the second argument, which corresponds to this parameter value right here. So I'm going to Control F, we'll replace that with the actual function that's getting passed in, and I'm going to call this var so we know this is a variable and not the function itself. Okay, here we go. That looks good, and then this is going to be the return value. So for the command string array, this is returning our string of commands inside of an array, and I'm going to rename this variable accordingly. And I'm just going to call this var command string array. Very easy. We'll call this copy2 just for clarity. There we go. And it does indeed look like we're performing some array operations. This just looks like a little bit of math, kind of an obfuscation technique to decide what array indices to remove and to move around, but we're doing the same thing regardless of whether we enter this if-else or if we have an exception and enter that catch statement from the try-catch. This is effectively doing the same thing inside of the loop, so I'm going to stop my deobfuscation process right there and just kind of allow this function to be. So I'm going to use a little bit of dynamic analysis to let this rearrange our elements for us. The next thing I want to do is look at the main work, which is inside of our try-catch statement, and this is going to be the final code that executes. We have our functions up here, which are setting up an array of string values. We have this immediately invoked function over here that's going to be rearranging our array values. But then I think the actual portion of malicious code is probably going to occur inside of this try-catch block down here. The next process of this gets pretty manual and repetitive. It looks like we have a lot of calls to these functions to try and add all of these different string values inside. This is just another variable that's pointing to our command string function that's going to be returning that command string, and then we're setting all of these values inside of here. Now what I'm going to do is I'm going to go through and replace all of these function calls with their corresponding actual string values so that we can make this code really clear of how it's executing and what strings it's trying to reference. Let me rename a couple of these variables before we go through and replace all of the strings inside of this method. Now let's take our ActiveX object, that's the one I talked about a little bit earlier that allows this application to interface with the underlying system, and this is getting command strings at a certain index, so it's calling this function that's defined up here. Now I want to get the actual value of this, so I'm going to execute this inside of my developer tools. Let me first rename this variable just for clarity. I'm going to find this, and let's call this var ActiveX object, so we can see where it's referenced later on inside of the code. And now I want to get the string values of this. What I'm going to do is I'm going to go back to my original code just in case I broke something up here as I was deobfuscating this, and let's run this inside of our console so we can declare these functions and have this function invocation so we can get the real corresponding values of the array. Now, I'm pretty confident this isn't doing anything malicious. This is just some setup code for the malware. But again, I'm running this inside of my secure malware analysis environment, so I'm not too worried if I do accidentally execute something kind of malicious. Let me go over to my code, and let's just add our function definitions to our developer tools. So I'm going to paste this in, add that function, go over to our other function, and our variable. Paste this in. Remember, this is the original malicious code before I started deobfuscating, just in case I broke something. And then I'm going to run this function, and this should effectively rearrange all of the elements inside of the array so that we can get their real values down here inside of the function that's doing the primary work of this malicious code. I'm going to copy this. And let's just dump this inside of here and have that execute. It looks like we're good. This executed properly and didn't have any kind of errors. Now we should be able to go over back to our code and take some of the function calls inside of here and get their real corresponding values. The first string that I want to change is down here, and this is going to get the array index of all of our commands and then get the string at that specified index, which is specified by this hexadecimal value down here. Now remember, I pasted in the commands from the original value before I started changing variable names. So what I want to do is, instead of pasting this in, I'm going to find the original method name of this, and then I'm just going to print this to the console to see what the string value really is. I'm going to take this, go to our ActiveX object, copy this method call. Let's go to our developer tools, and I'm just going to do console.log, paste that in, and there we go. That's the real string value that it's returning, so I can copy this and just replace this. And then we're concatenating another string, so I'm going to copy this. Let me put this in the correct location inside of our Deobfuscated code. There we go. Now I'm going to take this second value of this and print that to the console as well. And that's the second portion of our string that we're concatenating together. So we can actually get rid of this and simply put this to the end of the string. So now we see we're creating a new ActiveX object, and this is going to take some commands that are going to be executed on the system. So these are going to be taking some shell commands. This is really exciting because this is probably executing the malicious portion of our code. Now, continuing on, I'm going to do the same kind of thing, and I'm just going to replace all of the strings inside of this, all of these method invocations with their real string values, and do this over and over and over again, which is a really manual process. I'm going to speed through the portion of this since it becomes very repetitive after I do the first two. Let me take a look at the first one. First of all, let's rename our variable, since we're passing in a reference to a method. So again, this is just our get command string at index. We're just deobfuscating some more strings. I'm going to call this var get command string at index. So it's effectively invoking that method. This is just not a regular variable. And we'll replace all occurrences of that so that it's much clearer for us to see. And now I'm going to go through and I'm going to print out each of these values. Remember, I'm going to go back to my old code down here and print this, since this is the original variable name that I used inside of the code I was executing inside of my console. Now, first thing I'm going to do is I'm going to set this new variable that we're using through all of these occurrences. I'm going to set this equal to our function. So we'll copy this, put this inside of our console, and now we can invoke that method, since this is an indirect reference to that method. We'll just do console.log and we'll print out the string value of this. Console.log. Here we go. Now that's the string. Let me do the second portion of this. Same thing. Console.log this. And this should all start getting a little bit clearer. It's a very exciting process. And that's the second portion of our string. Since it's concatenated, we can just put it together. Now this looks like a map that is defining a key and then value pair. So the key is going to be this string, and then the value is going to be the corresponding string that is the second one following it. Now I'm going to speed through and do the same thing for all of these different values inside of here. Now I've gone through and I've changed all of those method references over to strings, and you can see the execution flow is getting way clearer already. This is really exciting. We've got our map with key value pairs, and you can see we're calling this map, which is being defined over here, and then looking for the key and then replacing those commands. And we're using our ActiveX object to run commands on the underlying system, and the commands are going to be coming from up here. Now what I want to do is I want to change the key calls over to their corresponding strings. So let me show one example of doing this. This is really simple. All I need to do is find the key here and then replace that call to the corresponding string. This is going to be the corresponding value. replace that. I'm going to perform the same operation for all references to this map and just replace with the corresponding strings. Again, I'm going to speed through this process since it gets a little bit tedious and a little bit manual. Now I've finished replacing all references to this map with their corresponding values. Anything looking for a key, I simply replaced with the value instead to make it much more readable. And you can see we've got this kind of clear string of commands that it looks like we're concatenating inside of this variable before we execute them on the underlying system. We are referencing our ActiveX object, and it looks like we're going to pass in our command string and execute that on the system. Now the final thing we need to do for this is actually put our commands together instead of being part of this while loop that's going to put our commands inside of this variable. I'm going to go through and do that. Let's first rename this variable. Let's call this var command to execute. Now this is a little bit of another obfuscation technique. We have this while loop and we're putting together all of these command strings based off of this switch case. We're defining our switch case up here. This is going to be our string that we're looking at, and it looks like this is our index value. First of all, let me clarify this. Go over here. Let's just do console.log for this integer value, just the integer 0, very simple. So I'm going to replace that with 0. And this is going to be our index. Rename that to var index. Much clearer. The last thing is our string. Now this is our index string. I'm going to rename this as well, just for simplicity. And this is a little bit funky. If you go through the string, we're splitting this based off of this character right here, and then we're going through index by index for the string that is stored inside of this. So each of these is the index that we're going to be using for this switch statement. So case 0 is going to append this command, case 1 is going to append this command, but our cases are defined by these values inside of the string. So what we need to do in actuality is start from 4, 3, then go to 1 and append those commands. So what I'm going to do is I'm going to take this, we start at 4, so I'm going to take this string, and let's put this over into a new file for simplicity. Let's move this over here. Now these are going to be the commands that are running on the actual underlying system. So we start with 4, then we go over to 3, we can append these commands. There we go. And then the next one is 1. I'm going to copy this over. There we go. And then we can keep going in order. I hope you're getting the hang of this and see what I'm doing. Again, I'm going to speed through this portion so that we can just get this process complete. Now I have my full set of commands that I put in the correct order on the right-hand side, and let's just walk through the actual behavior of this sample. Now the last two indices that we look at are 2 and 8. So if we go at case 2, this is using our ActiveX object to execute a command on the system. Let's clarify this number real quick. And print the integer value, just the integer 0. So we can replace this with 0. Same thing down here. Let me clarify this real quick. Just the integer value 1, very simple, beautiful. Perfect. Now we have the commands that we're building up, and we do this in order from here. Then we go to case number 2, which is using our ActiveX object to run a command in the background. The command to execute is going to be this PowerShell command, which is going to take a JPEG from this malicious IP address, download it, put it inside of this zip file, expand that archive, and then push this into the C users public folder. And then once we've finished with this case, we're moving on to the last case, case 8. which is going to run something called C users public shell.js. So we're putting this and expanding it into this shell.js. Now all this was doing was, this is a really complicated way of downloading a malicious file from an IP address, expanding this, putting this inside of this shell.js file, and then executing that as the final payload. Let me take a look at this IP address. It's very interesting. I want to double check in VirusTotal and see what other people think about this. Let's just go to VirusTotal and dump this in and see and verify that this is indeed malicious. I'm going to paste in this IP. And here we go, this is definitely malicious. So this is probably holding a malicious payload that is going to be downloaded and executed on the victim's machine. And my guess is it's going to be that async wrap payload. So it's going to remotely let the attacker access, control, and send commands to the victim's machine. Let's take a final look at the deobfuscated file. Remember, this was the original form of the file, all on one line and heavily obfuscated. And this is the deobfuscated portion, where we renamed all of the variables, we replaced all of the strings, we reordered the command strings so that we could see what commands were getting executed in the proper order of execution. So we'll go through here. Looks so much better, looks really beautiful. And then these were the final commands that get executed, where we're downloading a file and then executing it on the victim's system. So thanks so much for watching LaurieWired, everyone, and I'll catch you in the next video. It would require, like, a miracle. I'm 20 seconds behind. Oh, gosh.